Okay, so we're going to go ahead and graph this. Now, when you graph cosecant, when you graph some of these reciprocal functions, the key is to graph sine first. So we're going to graph sine as a guiding function because we know this is the reciprocal of it. So we're going to use sine to help graph cosecant. Alright, so let's go ahead and start this one. Okay, so we have 1, 2, 3. Here's my sinusoidal axis. 1, 2, 3, 4, upper bound. 1, 2, 3, 4, lower bound. Okay. Then my period is going to be 1 over 40 times 360, or 90? No, or just 9. 9. Alright, and then we're going to start at positive 40 degrees. So degrees, 49 degrees. Halfway between 40 and 49. 44.5. Halfway between 44.5 and 40. 42.25, and halfway in between 44.5 and 49 is 46.75. Okay. Now, sine, if we use that as a guide, sine would start at the sinusoidal axis as a positive amplitude, connect and go up to the upper bound at the second mark, connect, be at the lower bound on the 1, 2, 4th mark there, and then end of the sinusoidal axis again. So I can graph this guiding sine function in. Wherever sine is 0, keep in mind that your cosecant function is going to be, hold on, I'm getting a different pen. Okay. Your cosecant function is going to be non-existent. So sine is 0 here, here, and here. This is where my asymptotes go for my cosecant function. And then wherever sine has a hill, cosecant has a valley. And it follows the asymptotes in both directions. And wherever sine has a valley, cosecant has a hill. Okay? And then this pattern would occur every time. It kind of looks like you've taken this part of the curve of the sine function and flipped it upside down to get your cosecant. But what's in purple is actually the graph of that cosecant function. Alright, let's look at tangent. Tangent and cotangent. Tangent can be written as sine over cosine. So wherever cosine is 0, tangent has an asymptote. And wherever sine is 0, 0 divided by anything is still okay, it's still 0. So wherever sine is 0, you have a point on the tangent function that lines up with that. Okay, so let's go ahead and graph one. I'm going to switch to radian measure here to graph tangent. Let's go 19 of x minus 2. Okay. So negative 2. 1, 2, 3, 4, 5. Upper bound, lower bound. 1, 2, 3, 4, 5. There's my lower bound. My period. I'm going to flip the b value and multiply by 2 pi, so my period is 19, and I start at the value of 2. So to 19, halfway in between is going to be 10.5. Halfway in between these two will be 6.25, and halfway in between 10.5 and 19 is going to be 14.75. Okay. Now I'm going to graph the sine function and the cosine function to show kind of how tangent is related, because keep in mind that tangent is equal to y over x, or sine over cosine. Back to the unit circle. Alright, so sine, let's start here, here, upper bound, lower bound. So sine would look like this. Cosine would start at the upper bound and look like that. Okay, for the tangent function, wherever cosine is 0, so wherever cosine connects with that sinusoidal axis, which is right there, you have an asymptote. Right there again, cosine connects with the sinusoidal axis, you have an asymptote, because cosine can't be 0, the way tangent function is set up. Wherever sine is 0, 0 divided by anything is still okay. Sine is 0 here, that's going to be a point on my tangent graph. Here, that's going to be a point on my tangent graph, and here. And then with the tangent function, the place where it kind of turns to follow the asymptote is on the upper bound and lower bound, but it's halfway in between those two, because everything's very symmetrical. So we're going to be halfway in between, halfway in between, halfway in between. And then you have this little curve action going on to follow the asymptote. Curve action going on to follow the asymptote. And there's your tangent function. Now, you don't have to graph sine and cosine every time. And if this was cotangent, it would flip to be cosine over sine, and so then whenever sine is 0, then your function has an asymptote. So you graph cotangent the same way, but the asymptotes will end up in different places because then cosine's on the bottom. So they would end up here. Cosine's on the bottom. Sine's on the bottom, whoops. So they'd end up here, here, and here instead. But you'd have the same curvature going on, except you'd be going left to right, decreasing. Okay, the last one is secant. So secant is the reciprocal of cosine, where cosine has a peak or a hill, secant has a valley, so that still applies there. And this function is technically 1 over cosine, and so wherever cosine is 0, you're going to have an undefined, or you're going to have an asymptote. And so cosine is 0 at 90 and 270. Okay, so let's graph an actual secant function here. We'll go back to degree measure. 4, I'm going to flip it on you. 4 minus 3 of secant, let's go 6 theta plus 20 degrees. Okay. Four is my sinusoidal axis. 1, 2, 3 is my amplitude. 3, 1, 2, 3 is my amplitude. Okay, my period is going to be 1 over 6 times 360, or 60 degrees. And I start at negative 20. So here's my first period from negative 20 to 40. Okay. Now it's actually time to graph secant. I'm going to go ahead and sketch in cosine because this is the reciprocal. But also notice I have a negative amplitude, so you have to be careful there. Instead of cosine starting at a peak, well, let me finish my sentence, and then we'll go through and do our markers. Instead of cosine starting at a peak, it's going to start at a valley at 20 and end at a valley. Let's go ahead and figure out these individual marks. So negative 20 plus 40 is 20 divided by 2 is 10. Negative 20 plus 10 is negative 10 divided by 2 is negative 5. 10 plus 40 is 50 divided by 2 is 25. So there's my markers. So we're going to start at a lower bound for cosine. It'll connect there. Upper bound for the middle point. Connect and connect. And then if I was to sketch it in, it would look something like that. Now, secant, keep in mind, is 1 over cosine. So wherever cosine is 0, that's going to be an issue for my secant function. It's going to have an asymptote there. Cosine is 0 here, because it connects with the sinusoidal axis, and here. Okay. And then wherever cosine has a valley, your secant will have a hill. Same thing here, wherever your cosine has a hill, secant will have a valley. Okay. Notice that they don't cross over. Your secant function and your cosecant function will not be ever within that upper and lower bound. They'll always be on the outside of it. And they will follow the asymptotes. Okay. I think that's all that you need, at least at this point, to get started. I forgot to do it before. I can explain the various connections these functions graph have with sine and cosine. These are some of the connections here, but it's getting across the fact that these are reciprocals. So whatever's true about your original function, if you do the opposite of that, then that's true of your reciprocal function, secant, cosecant, or cotangent. And I would be looking more for, with tangent, that you show the relationship like we drew here, wherever cosine is 0, that's an issue because tangent is equal to sine over cosine, so you'd have to draw an asymptotes. And then wherever sine is 0, you'd have to have a point on the sinusoidal axis. And it goes from there. Alright, that's it for those notes.